Okay, so we have our given, we have our unknown, we have our equation, we've substituted in, and that takes care of guess, and then we have CUBS. C stands for calculate. How many people have a calculator? Get out your calculator. Punch in your numbers.
13.5 repeat.
13.5 repeating? Now, remember, one of the things that we're going to do at the very end is we're going to stop at 2 to 3 digits or a reasonable number of digits, and then we're going to, or you're going to do sig figs. Which one would you like to do here? Shall we just stop at a reasonable number of digits? What seems reasonable here? We could do 4, we could do 3, right? I mean, if I were to write this out, it would be 13.555. That's not a good number, right? So you could say, let's round that to 13 point. Look to the number to the right. That's a 5. When you have a 5 there, do you round up or do you round down? You round up. So instead of 13.5, it's going to be 13.6. No. Because in chemistry and in physics and in science in general, is it reasonable that our answer goes to infinite digits? Does that make sense?
No.
No. Right? We don't know anything that precisely. Okay? So you either need to stop or you need to do significant figures. So this is just stopping. So we have 13.6. We also need our unit. What is our unit? Kilograms over liters. And we need to box our final answer. Is good? Okay. For those of you doing the enriched stuff, the rest of you can just chill for a minute. 61 has 2 sig figs. 4.5 has 2 sig figs. And we always, when we're multiplying or dividing, we round to the least number of sig figs. So here it's 2. So to sig figs, it would actually not be 13.6. It would actually be 14 kilograms per liter. So that's the enriched there, okay? If you're bored and you're waiting, you can work ahead, okay? There's no need at this point. Would you like to do another one together? Shall we do another one together? Okay. Here we have, again, our formulas are given here. We have our unknown. We have a given quantity and a given. Remember, you have to say to yourself, what am I measuring when I bought 40 seconds? Because what I really want to do is I really want to say volume is equal to 5 liters. But I'm not going to say volume is equal to 5 liters for 40 seconds. What am I going to say instead? I'm not going to say volume if it's seconds. I'm going to say time. And what is the symbol for time? T. And what is the unit? Seconds, and we abbreviate seconds, S. So what we're going to do for our seconds is we're going to write, instead of writing volume equals 4 liters, we're going to write time T is equal to what? Then you have to go back to the question. And you say it's equal to 40.0 seconds. Okay. Let's do that again for our 156 meters. We're not going to say T equals 156 meters because meters don't measure time. What does meters measure? Meters measure distance. So we're going to write, what's the symbol for distance? D. And the abbreviation for meters? M. So we're going to write, if we wanted to write something similar to T equals 40 seconds, what would we write? Instead of T, we would write D. Instead of 40.0, we would write 156. And instead of seconds, we would write meters. Is good? Okay. So we would say our given, we have T equals 40.0 seconds. Our other given is distance equals 156 meters. What's our unknown? Velocity. What's the symbol for velocity? V. So we're going to say V equals, and what do we put after that? Because it's the one we don't know. We just put a question mark because it's unknown. Okay? What is our equation? Could you get the door, Alfred? Please. Thank you so much. We have two equations to choose from. Which one will we choose? The first one or the second one? Second one. Little v is equal to d over t. Now, technically, you do not need to write the equation and the substitution separately. I would just do it all on one line. I would write v equals d over t down here, and then I would put another equals sign because I'm writing a mathematical sentence and it makes sense to go from either left to right or top to bottom, okay? And because I don't have a lot of vertical room, I'm going to go from left to right. What am I doing when I substitute? Yeah, what I'm going to do is I'm going to go find my value for D, and I'm going to put it on the top, 156 meters. And I'm going to find my value for T, and I'm going to put it on the bottom, and that is 40.0 seconds. And then we do our division. 156 divided by 40 equals 3.9. Does that seem like a reasonable number of digits? Yes. So we can just stop there. Okay? But we also need to have, what else do we need in our answer? Units. What are our units? Meters over seconds. So you just read it from what you've got there. Meters over seconds, and then put a box around it. If you're interested in the enriched portion, how many sig figs in 156? 3. How many in 40.0? 3 sig figs. So how many sig figs do we need in our answer? 3. So instead of 3.9, it would be 3.90 meters per second, and that is our enriched answer. Okay? But for most of you, you'll probably be like, 3.9 looks good, and that's just perfect. Okay? Do you guys think you could try the next one on your own? Do you want to give it a go? Or do you want me to do it with you? You want to do it on your own? Give it a go. Try it on your own. Yeah, for sure. Yeah. Hi. Yeah. So when we have that 40, we'll notice it's not 40, it's 0. Yeah. And that means that we have 360. And so what's the smaller number? 3. If that was a 2, I would go 2. Yeah. I'm also going to start writing it up here, so if you get stuck, you can take a little look, okay? So if you're like, I don't know, Once you're done, you can check. I'm going to put little check marks beside everything you get a mark for. Okay, so that question right there is going to be out of 13. Because you're going to get a mark for saying V equals 0.15 and liters. So you get 1, 2, 3 marks there. You'll get 1 mark for saying M equals 2.90, 1 mark for 2.90, and kilograms. Our unknown density equals question mark. Our equation, I wrote it down here. You get a mark for writing the equation. You get a mark for plugging things in. This is the substitute. You get a mark for doing the calculation. Oh, actually, I forgot the calculation. And then you have to stop at a reasonable number of digits, have your unit, and box your answer. And there's 13 things that you need to do there, and you're good to go. Yeah. I do. Little one?
Yeah.
Yeah.
This was only 6 because the second number beside it raised it. So it's 3.
Anyone interested in the sig figs on this question? Yeah? Okay. How many sig figs in 2.90? 3 sig figs. How many sig figs in 0.15? 2 sig figs. Remember, zeros at the front don't count. If you have 2 sig figs and 3 sig figs, you go to the smaller number. So you, instead of having 19.3, you would just have 19 kilograms per liter, 2 sig figs. Okay? We have one last one, and you'll notice that I have gotten rid of writing down, tell me the given, tell me the unknown. I've just left it blank. But you can feel free to be like, I need my given. I need my unknown. Okay? See if you can go through the steps on this next one. Okay? Oh, that's a good question. Let me see.
And you're saying
Yes. Just 29.6. Yeah.
Hey, something with I was a no, yes, he was. You know, like, so,
Yeah, you're gonna round here.
All the backwards, bro, what? I don't think you need a support. Yeah. No. Okay, stop. Right, this is. No.
I'm going back to the top so I can take a picture.
For sure. Yeah, yeah.
Okay, look, you need to understand. You just don't.
We good?
It's basically. You know, traded.
I like
Yeah, but if you not, let's say it's not bad, it's a big event.
If you want, I would say, right, Let me talk with.
Every day, I always. Next time.
Okay, folks. Sorry. Yes. So if you get a number like this,
I thought that.
you get to choose. You can say 29, or you can say you would need to, if you're rounding to the 0.1 position, you would have to look to the right and you would have to say that's bigger than 5. So you're going to round up. So you could say 29.1. And if you want to go to 4 digits, that's even more confusing. You would have to go to 29.10. Anyway, let's not worry about that.
I did 29.07. That works.
29.07 works. There we go. Yeah. Shh. So any of these would be okay. But what about the enriched? What about enriched? If you're not doing the enriched, then just shut your mouth for 1 second so we can finish this. No, if you're doing enriched, you say I have 3 sig figs here, and I have 3 sig figs here. Sorry, that looks like a B. And then you round the answer to the smallest number of sig figs in the question. In this case, 3 is the same as 3, so there's no smaller number. So you would just round it then to 29.1, 3 digits. Okay? Is good? Okay. And I would like to show you guys a little video, if I can find it. What have I done with it? What's that guy's website? What's he called? What's his name? Shoot. That guy. That guy. I know I'm being not at all helpful at all. Okay, hang on. Let's see. Is this me or is this the thing?
Brian.com.
No.
Tiger Woods. Oh, Sean Combs.
No. Nope, that's not what we want.
Spence.
Yeah. We don't want Spence. I have 121 subscribers. How awesome is that? And I do nothing but teach science.
33 views. 33 points for me.
Right? Okay. Oh, that's what I want. Current and voltage matrix education. Current and voltage matrix education. Is this the one? Yay! I found it. Okay, everybody, you need to sit in your own seat, Brayden, and face the front.
I'm fixing his house.
Oh.
Tell him to see how we made progress.
Okay.
I didn't know I can.
We're going to look up here and we're going to watch the video, okay? Because next day we're going to stop doing, density and velocity because we're supposed to be doing electricity. So we're going to use that same method to solve current and velocity problems. So let's take a look at this. We need to turn up the volume.
Is that the guy from
It's that guy.
the potassium guy?
Yes, that's the word I was looking for. I'm like that guy from The Thing. The Thing is Veritasium, yeah. And this was before he started doing Veritasium. So this is like from the olden days. Okay. Shh. Faites attention, s'il vous plaît. Which means stop looking at whatever's on your desk. Is it your phone? Okay. Stop looking at whatever's on your desk and look up here. Have you guys heard of amps?
Amplitude.
Oh, yeah. Amplitude. So amp is also a shortened form of coulombs per second. And what is a coulomb?
One thing.
It's a bucket of charges. In this case, usually electrons. So it's not a literal bucket of electrons, but it is a particular number of electrons. 1 coulomb is, it's a big number. How many electrons in a coulomb? 6.25 times 10 to the 18. Now, look at that number. I don't know if any of you remember how to do scientific notation, but basically what times 10 to the 18 means is that you're going to take that decimal place and you're going to move it 18 places to the right. So it's going to become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Electrons. Hush. Hush. Do you want to come to my house and fix all my calculators?
Yes.
Yes? Okay.
No,
I have like 17 calculators at home. Not quite. I have like 3 that need replacing the battery. Anyway. Does everyone want to say 6.25 times 10 to the 18 electrons every single time?
Yeah.
Probably not. So that's why we give it a more simplified name, the coulomb. And this is a really hard number to visualize. Can you guys think of a number that big?
No.
No. So we say, here is a bucket. Oh, that's a terrible bucket. What is wrong with my drawing skills? Here's a bucket, and it contains that many electrons. So you can think of 1 coulomb as being a bucket of electrons. You don't need to know the exact number. You just say there's a whole heck of a lot of electrons in that bucket. Yes? All right, let's continue with our little video here. Okay, I'm going to go back, and all of you who are looking at something else other than the screen, that would be Grace and Nick for sure. You need to be looking up here. Watch the electrons flow. I need everybody's eyes there. Everybody's eyes here.
I know between that.
Una? Micah? Eyes on the screen? Why is there no current flowing in a lake? Like why is the lake just sitting there? Why is it not like pouring out one end? It's stable. Is it tilted? No. It's both sides of the lake are at the same height, yeah? It's flat, essentially. I mean, it's got a scoop to it, but the water is flat. Wow. Which has higher potential energy? This thing up here or that thing down there? Which one has more potential energy? Up or down? Up. So if I had a ramp, if this is flat, the pen does not move, yeah? But if the top and the bottom of the two sides are at different potentials, this will go from higher potential to lower potential. And that's the same thing that's going to happen with our electrons. They're going to go from an area where they are less stable to an area where they are more stable. Okay? And that's it for today. There is no homework unless you didn't finish last day's. Okay?
No, okay.
Thank you, sir.
The problem. No, it's too fast now.
Oh, yeah, thank you.
I found the solution. I will buy some. Yeah, well, Hey, look. Hey,
You're welcome. I just ran my. Oh yeah, absolutely. Anytime. I can still see proper, right? It's all good. No. I suck at it. Milan,
Oh, that's true.
Emma, John,
Ready?
Amy.
You're allowed to retake these as.
You can retake the quiz, yes, but this is your test. We'll start with that. Where are you, Abby? Oh, you are.
Such an I you didn't see how
Jade,
I'll probably go.
Baran.
Yeah. Your test.
Yes,
Oh my God.
there you go.
Thank you.
Oh, I forgot to put them back in. Oh, no. Okay, let's see. Let's hope I brought them.
I already know.
I meant to.
I already know it.
I don't know.
I forgot. If I
Oh, here we go. I'll count separately. Emma, I've got your multiple choice here. Come on, multiple choice.
I got quick.
John. Choice. Amy, multiple choice. Okay, yours is here. Go. Baran? Jamie. Go. All right, and now I'm gonna grab the rest of these and put them together in cups and make those out. Okay. Who have I got here? I have. That's my answer key. Jonah. There you go. Edward. No, Edward. Dorothy. Sally.
I was supposed to. I didn't know you do that.
Sky? No Sky yet.
I only did. Okay, I think I was thinking of.
No Olivia? No Olivia. Mateus. Felix. Tara. No Tara. Yeah. I understand.
I was not looking down at the floor and I was
I'm gonna try to do it during lunch. Yeah, maybe. Are you going to But I don't know. I think
oh my god. Right, well.
and I don't think I'm gonna be wasted and
You're done with it, they can just pop in.
12 a.m.
These? Yeah, that just goes inside.
Thank you. I'm actually pissed off.
Tara. Sky. There you go.
Thank you.
Olivia. Hello.
It's not full six.
So what happens is you do a subtraction and you end up with when you do this subtraction, you end up with 1.18. Yeah, which is 3 sig-figs.
What is?
Oh, yeah.
Oh, can I get 0.5 back? Because like I just misread my calculator. I read through the equation right.
What does that mean? Go ask her. So I think I got the point. Right.
I took 0.25 off for that and 0.25 off for that. Okay,
Can I get like a 0.25 back for just
no,
In this class.
sorry.
Yeah.
Hi.
I was wondering what this.
Oh, it means that you've gone through this huge explanation.
But did I not just say it?
No. Yeah, they're further from the nucleus because the attraction is weaker. But they're further from the nucleus because they're in a higher energy level, so they're further from the nucleus.
Yeah, but I said that there was more.
Yeah.
Oh, you're saying.
Yes.
Something there to say
Yes.
why.
One more occupied shell
Oh.
and higher energy level occupied shells are further from the nucleus.
Okay, so I can't just say.
Yeah.
Okay.
And this one is really like, it has nothing to do with it. That weaker bit, actually, I think that was the part that was the problem. So because the valence electrons. No, it's okay.
Okay. But it's not because of the occupied.
No,
Okay.
no.
Okay.
Oh no, maybe it was the occupied. Yeah, it was the
Maybe it
occupied.
was like the.
That was the, no, it was the occupied
Oh.
that I took off the half mark for.
Oh.
This was just kind of like, you could have just gotten, like, you didn't
Yeah.
have to say that part, you could have just
Yeah.
like, left it at that. Yeah.
Okay.
I just like want to know like,
Yeah.
how C explains like why.
Oh, why the electronegativity of Cl is less than F? Because Cl is larger than F. The repulsions among the electrons in the valence shell Cl are less than the repulsions electrons in the valence shell are. That one's definitely wrong. It's definitely wrong. Oh, it's not D.
Oh yeah, I know it's not D. I'm just wondering why it's C.
Oh, okay. Because I'm reading D and I'm like, well, it's not D. Well, because none of the other answers are correct, for starters. The Cl bonding electrons are more shielded from the positive nucleus. So chlorine has its nucleus here.
For all of these are present in 3.
2, 3. Chlorine.
Oh yeah. Look at that on the scale.
Bonding electrons for chlorine are going to be here. Bonding electrons for chlorine are going to be here. So this has. What's the answer? Yeah, they're more shielded. Because we've got one shielding shell, and this one we have 2 shells shielding.
I
I would rate.
just put a.
Oh.
Yeah. You could also say they're further from the nucleus, but that's not one of the options.
I let this line. Look, I forgot to put that. Is this other one? I forgot to solve the. I just put.
Oh, this is like say this is the 3. Okay.
I don't.
Oh, I was just supposed to write like this after I talked about that.
Yeah.
Oh,
Yeah.
I kind of just mentioned this and I didn't like explain why this is.
Yeah. Yeah.
Okay, I just put this like on top.
Inside. Yeah, just happening. There we go. Perfect. Thank you. There you go. No.
Okay.
Great. Next one.
Mm-hmm.
Like
Why does an ion of phosphorus have a larger radius than a neutral atom of phosphorus? It is because all the electrons go into the same shell, yes? And the number of core electrons has stayed the same and the nucleus has stayed the same, yes? So the only thing that's different is that there's now more electrons in this shell. So they repel each other more, so it gets bigger.
Isn't this the thing that like this is like saying
Okay.
Yeah? Okay, I don't know where this number came from. Yeah, so basically your algebra here.
I think I have to read.
Yeah, you would need to put them together. But let's just pretend that it was these numbers, okay? You lost your x, right? So right? And then so if you had carried on,
X would I be right?
you would have ended up with x and that would have been the correct number. Okay? Yeah. So I don't know what happened here. This was just like, I don't even know what's happening. I don't know why we have 20x. I don't know why it's equal to 19.99. I got lost over here. But this was good, other than the fact that you wanted to add in those. Yeah? Yeah. Yeah.
And over here, I'm lost with the question actually.
Okay.
Because I didn't know how to do this.
Okay, so what we have here is we have the energy per photon that it takes to break a bond. Yeah. And here we have the kilojoules. This is the. Sorry, this is the energy per photon.
Okay.
This is the kilojoules per mole of photons needed to break a bond. Okay. So if you change this into just, instead of kilojoules per mole, if you change it to kilojoules per photon, then you change it to joules per photon, then you'll have the minimum energy needed to break the bond,
Okay.
right? And then you can compare it with this, and you can say, does this have enough energy to break that? If this number is bigger, then you're good. If this number is smaller, then you're not good. Yeah.
Okay. So it's supposed to be a yes instead of a no, because I said no. Somehow. Okay.
I haven't even taken bio yet.
I'll also hand back your geometry quizzes. Jonah, Mateus, Baran.
Please hurry up, right? Please.
Tara,
No, not yet. Girl, I just
Olivia,
she just told me to prepare.
John, Sally, Dorothy.
Can I reach it?
You can. Aditya, Jade, Milan, Sky,
Yes.
Emma,
Okay.
Amy. Thank you. You're welcome. Edward, you did horribly.
I forgot my degree sign. Can I retake it right now and just draw the degree sign?